Hello everyone. It's great to welcome you to the inaugural David Clarke Memorial Lecture, which today will be delivered by our esteemed colleague and friend, Professor Alan Schoenfeld. My name is Carmel Masishi. I'm a lecturer in Maths Education at the Melbourne Graduate School of Education here at the University of Melbourne. And some of you may know me as the Centre Coordinator of the International Centre for Classroom Research. Whether our paths have crossed or will cross, I'm pleased to have you join us today. I would like to begin by acknowledging the traditional custodians of the lands on which I stand. I'm in Melbourne, which is the ancestral land of the Wurundjeri people of the Kulin Nation. I pay my respects to the elders, past, present, and emerging, for they hold the memories, the traditions, the culture and hopes of Indigenous Australia. If you wish to acknowledge the land of wherever you might be, you're welcome to indicate the traditional custodians of the lands on which you stand in the Q&A function of this webinar. Thank you for joining us today to honour our very own Professor David Clarke and his extraordinary contribution to education. I'm fortunate to have known David from very early on in my teaching career. He was an inspiring teacher, and I was exposed through him to cutting-edge classroom research. David was known for exploring big ideas and small ones in conversation over much coffee, and I'm sure many of you in the audience have shared in that pleasure. Today, we are joined in this webinar by the Dean from the Melbourne Graduate School of Education. A big welcome to Professor Jim Waterston, and my colleagues from the ICCR, Professor Jan van Driel and Dr. Esther Chan are also joining us. And of course, from the University of California at Berkeley, it is my pleasure to welcome Professor Alan Schoenfeld, David's colleague and friend. Today, Alan will deliver his lecture titled Reflecting on the Learner's Perspective. Having been involved in David's 16-country Learner's Perspective study, I'm very much looking forward to hearing about your perspective, Alan. Esther will moderate the question and answer segment following the lecture. You are invited to contribute questions and comments in the Q&A function of this webinar. Please note that today's event is being recorded and will be made available at a later date. However, before we hear from Alan, there are two short items on the agenda. First of all, I would like to invite Jan to share our vision for the ICCR, reimagined as a research hub.
Thank you, Carmel, for the opportunity to speak today on this special event and say a few words about the history, but especially the future of the ICCR. The ICCR was founded in 2003 as the International Centre for Classroom Research by Professor David Clarke as a major international research facility at the University of Melbourne, specializing in the collection, storage and analysis of data related to the study of teaching and learning in classrooms, mostly mathematical classrooms. Since its establishment, the ICCR has been hosting a lot of internally and externally funded projects with international cooperators. And you may see a quote at the bottom of this slide, which reflects the opinion of one of the reviewers of those projects about the work that was done under the supervision and led by David Clarke. Without going into details, and I don't have that much time, I would like to highlight just out of all the ICCR projects, the latest three that are actually still, that we're still working on, particularly Carmel and Esther Chen. One is the Learning from Lessons project, which is an international collaboration with groups of researchers in Australia, China, and Germany. And it's looking at what teachers learn from the act of teaching a lesson. This is about mathematics lessons and mathematics teachers that were developed. Lessons were developed to stimulate teachers' reflection, to make visible the process of teacher learning and make teachers aware of how they actually learn from what they're doing while they're teaching and reflecting on that teaching. This is a project that is funded by the ARC, the Australian Research Council, and is now being concluded by Dr. Esther Chen. Another project that some of you in this audience may well be familiar with is the International Classroom Lexicon project that was set up by David Clarke a long time ago, and includes collaborations with people in 11 countries. Just recently, a book was published, edited by Carmel Mesiti and others. The Lexicon project was set up to initiate a cross-cultural dialogue to identify which pedagogical terms are being used in classrooms in different parts of the world, and how these tools can be used to categorize, interrogate, and enrich classroom practice, research, and educational theorizing. And finally, to conclude this very brief overview of ICCR work, the Social Unit of Learning project is another project that is funded by the Australian Research Council and currently led by Esther Chen. It has, again, a very strong international and multidisciplinary component where researchers with very different backgrounds are using different analytical frames to code the same set of data, which leads to very interesting foregrounding of very different aspects of student social interaction in learning processes in the mathematics classroom. From now on, however, there is we will continue to use the ICCR acronym, but we've agreed to change the name from International Center for Classroom Research into International Community for Classroom Research. The reason for this is that the ICCR was a research center established at the University of Melbourne, but we have decided to change that from what is internally now called a research hub. For people who are working with the ICCR, that will not make a difference. It makes a bit of a difference for the people who work at the MGSE within the ICCR, but I won't go into detail to tell you what that means. That's we decided to use the word community because we think that is reflects well the way that the ICCR has been set up, and would like to see itself into the future as a platform for researchers all over the world who are interested to investigate classroom teaching and learning, both physical and virtually. We're not thinking of the classroom necessarily and exclusively as a physical space anymore, as this last year, of course, has taught a lot of us to teach in different ways. And we would like to see that as part of the ICCR scope. Also, we were not limited to teaching and learning in mathematics classroom. We could also look at teaching and learning in other subject areas. And the use of video may still be an important element of the research that we're doing, but again, we're not exclusively limited to using video data in the research. So we would like to build and continue to work with the international network that David Clarke has established in a supportive and collegial, or in David's word, charitable way. And we will also continue the research classroom at MGSE that some of you may be familiar with in future projects. However, this facility will no longer be managed by the ICCR, and more about that in a second. So finally, what we will do and the activities that we will organize as ICCR are on the right side of this slide. So we will continue to have monthly group meetings, and many of you have been attending those meetings that were not held in 2020, but until 2019 they were there, and we will resume that activity in 2021. We will have an annual David Clarke Memorial Lecture, as you know, tonight's the inaugural version. We will be looking for opportunities to visit our colleagues internationally and host visits of them, as the ICCR has done in the past, organizing joint symposia, working together on grant applications and on research projects, including supervision of graduate researchers. All those activities were part of the ICCR in the past, and we hope to continue those activities in the future. So finally, the three people that are currently leading the ICCR hub together is apart from myself, is Esther Chen, who I've already mentioned, Carmel Mesiti, who you've already seen, and myself, I am a professor of science education, so that also reflects the broadening of the scope from just only mathematics in the ICCR. And I'm happy to mention that I'm on next year I will be working on a project funded by the Australian Research Council on the adaptive expertise of primary teachers who are working interdisciplinary in math and science, a project that I think is really interesting from an ICCR perspective. And that concludes my contribution for today. Thank you very much.
Thank you so much, Jan. And I'd like to echo Jan's sentiment. We hope that you choose to remain in touch with the ICCR, with our hub, and participate in activities as you have done previously, wherever in the world you might be. If you were wondering about the lexicon book, it is in production and we're expecting it to be published May next year. So hopefully you can look out for that as well. I'll now hand you back to Jim, who has a special dedication to make.
Thank you, Carmel. It's an honour and a privilege to speak with you all today on such an auspicious occasion that is both a celebration of a life well lived and a time for reflection. On the 25th of January this year, the Melbourne Graduate School of Education lost a dear friend and a highly valued colleague in Professor David Clarke. David joined the University of Melbourne in 1994 and established the International Centre for Classroom Research in 2003, as Jan has just told you. He was promoted to a full professor in 2004. David was an international leader in video-based research methodology, and his substantial research program has contributed greatly to broader educational research practice. He leaves behind a large body of work, multidisciplinary international networks, and innovative digital research programs. Researchers continue his legacy through their work in cross-disciplinary teams using participatory video, video elicitation, and video-based fieldwork, which provides shareable, multimodal and real-time digital data. In addition to attracting funding from national and international agencies, David published 12 books, over 50 chapters, 70 refereed journals, 90 refereed conference proceedings, and he supervised more than 20 doctoral students to successful completion throughout his career. The list of active collaborators associated with David's research program is substantial, numbering more than 55 research academics plus associated research students and research assistants from across the globe. As we know, David was a generous mentor, scholar and friend. He happily and willingly gave his time to all of those around him, colleagues, early and mid-career academics, his students, friends, and of course, his much cherished family. He loved his work and would inspire others with his mantra of, you should always mix work with play. Work on what you love doing while you get paid to do it. And I think the pay bit's just as important as the love, I think. His passion and dedication to his work was infectious, and he seized on every opportunity to learn, collaborate, and discuss research. Throughout his illness, David was visited by colleagues from all around the world pre-COVID, a testament to the lasting impact of his work and the deep respect he was held in by those who knew him. Not long after David died, we sought permission from the University of Melbourne Council to rename the well-known room 417, where David did his work with such great passion in the Kwong Lee Dow building, to the David Clarke Research Classroom. Earlier this week, still under COVID restrictions, Carmel, Esther, Karen and I visited the classroom to inspect and admire a wonderful new plaque affixed to the entrance of the David Clarke Research Classroom. David's role in developing and promoting this innovative research facility made this a most appropriate way to honour his memory. So I'm delighted today to officially launch the newly named David Clarke Research Classroom. And if we've got our coordination together, there'll be an unveiling of that plaque. As the images show, the classroom has an adjacent video control room in which researchers can observe 16 channels of video capture. It is both comforting and very appropriate for David's name and amazing legacy to be permanently enshrined at MGSE through the naming of this classroom. So as I hand back to you, Carmel, I'm sure I speak for everyone when I say that we all miss David, but through his classroom we will continue to be inspired by him and his groundbreaking work every time we walk into the newly named David Clarke Research Classroom. So thank you for the opportunity, and I'll hand back to you now, Carmel.
Thank you, Jim. It's a really lovely way to honour David's contribution to MGC and education more broadly. And I think it will be a special experience in the future to teach in this classroom. Earlier in the week, Sharon, David's wife, shared with me a message of gratitude from the Clarke family. I'll share it with you now. A strong focus for David was building communities of researchers across disciplines, institutes, countries and cultures. So it is truly wonderful to see that his legacy will continue through this next iteration of the ICCR. On behalf of our family, I would like to express our heartfelt thanks to Professor Jim Waterston and the Melbourne Graduate School of Education for honouring David in this way and for keeping his memory and legacy alive in such a tangible way that captures what David strived to build. We also would like to thank Jan, Carmel and Esther for their part in making this happen. And our sincere thanks to Professor Alan Schoenfeld, David's longtime colleague, friend and compatriot in the pursuit of fine food, wine and conversation wherever in the world they would meet, for giving this inaugural David Clarke Memorial Lecture. This is a special moment indeed. Sharon LaFontaine and the Clarke family. It is indeed a special moment, and now it's my pleasure to again invite Jim to introduce our guest speaker.
Thank you, Carmel. I'm delighted to introduce Professor Alan Schoenfeld, the Elizabeth and Edward Connor Professor of Education and Affiliated Professor of Mathematics at the University of California at Berkeley. Professor Schoenfeld is a mathematician by training who studies issues of mathematical thinking, teaching and learning. He has served as president of the American Education Research Association and has been awarded the Felix Klein Award for the Lifetime Achievement in Mathematics Education Research by the International Commission on Mathematical Instruction. This award is the highest international distinction in math education. The award citation noted, Schoenfeld developed a keen interest in mathematics education early in his career and emerged as a leader in research on mathematical problem solving. He shows a lifelong pursuit of deeper understanding of the nature and development of mathematical learning and teaching. His work has helped to shape research and theory development in these areas, making a seminal impact on subsequent research. Professor Schoenfeld has more than 200 highly cited publications in mathematics education, mathematics education research, and educational psychology, including his highly cited groundbreaking book, Mathematical Problem Solving. His main research focus is on the Teaching for Robust Understanding framework, which concerns creating learning environments from which students emerge being knowledgeable and flexible thinkers and problem solvers. I now warmly invite Professor Schoenfeld to present the inaugural David Clarke Memorial Lecture. Thank you.
Well, thank you very much, Jim, for that lovely introduction. It's wonderful to, quote, be with you as much as one can virtually. It's a shame that I can't be physically with you, and I hope we can remedy that sometime in the future. And more importantly, it's wonderful to be here as ICCR takes wing, takes flight in new directions. The change in name to include community is so David in so many ways, because he was all about building community. I'm delighted to and honored to be here and to have the opportunity to help kick things off. So let's start where things matter, and that's with David, because ICCR is poised to take its next steps thanks to the wonderful work that David did, both large in terms of big picture international collaborations that were extremely valuable, and micro in the sense of analyses that really helped us understand what was going on in thinking and learning. So I'm going to start with what may seem a little bit strange. I'm going to start with two anatomical kinds of comments. The first is about shoulders. I think most everybody knows the first one, which is the famous quote from Sir Isaac Newton: "If we can see as far as we can, it's because we stand on the shoulders of giants." And when it comes to understanding classroom dynamics, understanding teaching and learning, we all stand on David's shoulders. The other metaphor is a personal one. You probably all know the image of a person with a devil sitting on one shoulder and an angel sitting on the other giving advice. Well, my personal version of that is there is a very small number of colleagues who have been important enough in terms of ideas so that I've done what I can to internalize them. And when I work, they sit on my shoulder. And a common part of what I do when I'm in the middle of working on something is to ask myself, what would David ask? What would David say? And the image on my shoulder feeds into the ways that I think. So that's shoulder. The other part, of course, that matters is heart. And that's the core of David. Everybody who knew him, if asked the question, who is the kindest, who is the most thoughtful person you know, would answer David. It's not even close. The rest of us get, excuse me, the rest of us get calibrated in milli Davids. So I'll turn to a different part of heart, which is the work at the heart of David's agenda. And that's understanding and supporting powerful teaching. And that's going to be the main theme of what we talk about today, and central, and I think really important, the leitmotif of what I have to say will be David's key phrase, the learner's perspective. And I think it's critically important that even though we do a lot of talking about teaching, David focused on the learner and the learner's perspective, and that's going to be central in various ways to what I say from here on. So I'm going to be talking about thinking, teaching, learning, mostly mathematical, although I'll say a little bit in response to what Jan said about how these ideas generalize not only to science, but any discipline. And I'm going to theorize the space that we're going to look at from the inside out. The inside, if you're thinking about mathematics, is thinking mathematically. But of course, where most of that takes place, or where most mathematical learning takes place, is inside the learning environment. You know, it's inside classrooms for the most part that we get our sense of what mathematics is, who we are as mathematical people, and so on. And that, of course, is deeply affected by the cultural surround. So I'm going to start with the circle at the middle and then expand out. So the goal for students is that they learn to think mathematically. And the question is just what's involved in that. I'm starting with that because every time we teach, every time we set curricula, every time we set assessments, we should be thinking about what's the real goal state and what are all the things we should be thinking about that matter in terms of what goes on in the environment. And that turns out to be a lot more than what we usually focus on, which is mathematics, facts, and procedures, and processes and practices. So in the words of P.D.Q. Bach, if you're familiar with the problem-solving work, prepare to hear a few themes that you've heard before. And I'll go through them fast, but the core idea is these are the things we should be concerned about with regard to student learning. The first being the things that are the standard focus. Content, what you can do, whether you can produce mathematical knowledge, whether you can do problem solving, etc. The second, which has gotten a lot of lip service, but not nearly as much active focus as it should, is mathematical problem solving strategies. The idea should be to help students learn enough so that when they leave our classrooms, they can solve problems we haven't taught them how to solve. Then they can use the knowledge they have. But as I'll explain very briefly, fundamental aspects of mathematical thinking also include aspects of metacognition, in particular monitoring and self-regulation, and very, very important, and I know it's been a focus of recent work in the center, the whole notion of beliefs and dispositions, how you are treated in the classroom, how you experience the classroom, shapes your sense of what the mathematical enterprise is, who you are mathematically, that's your identity, things like your willingness to jump in and do something mathematically. Those are issues of agency. So I'm just going to give a couple of one-liners about each of those. We could spend tons of time on each of them. But it's important to think about them because these are the outcomes that either do happen or that we would like to have happen in classrooms. The first one, the question is, what's the content and practice outcome? And the point simply is that there's a lot more there than we normally think about and that meets the eye. Knowledge is complex. What we'd like is for students to walk out of classrooms having habits of mind such as looking for patterns, not simply when they're given an exercise that says look for patterns. But if you learn to think mathematically, you do that naturally. If you've seen a pattern, making conjectures, asking, what should I believe that? How can I believe that? Let me try to disprove it. Let me try to prove it. Thinking naturally to look at things in different ways, use different representations, make connections between them. The not very well-defined word, but I think it's critically important, is our real goal is for students to emerge from our classrooms as mathematical sense makers, for them to walk out with a sense of the discipline and a sense that they can do it. That's the agency and mathematical identity that I was talking about before. And those take time and experience to develop. And that's only one of 4 categories. As I mentioned before, problem-solving strategies take time to learn. The difficulty and complexity of them have been tremendously underestimated. The bottom line is students can learn to become effective problem solvers if given the opportunities, the practice in doing so. One of the things I did, I have tenure and I'm a very nasty person, is I would put problems on my final exam that I found in a problem-solving book and I didn't know what to do with. I wanted to see what my students could do with them. And often they solved problems I could because what they had learned was to be mathematical thinkers. And that's really the goal. Issues of metacognition very, very quickly. Here are some timeline graphs that indicate typical behaviors. This occurred more than 60% of the time, and now there are thousands of graphs like this. When you give a student a problem out of context, more often than not, they read the problem, pick a direction, and go off doing something. And if they're going off and doing something, even if they know how to solve the problem, if they don't stop themselves and move in the right track, they don't get to solve it. This was a graph of a faculty member working a problem thrown at him out of the blue, two-part problem. Each of those little black triangles is a time that the problem solver said, geez, I'm not sure this is the right direction, or maybe I should give this a few minutes, or maybe I should start again. And it was all of those things that ultimately led to his reconsidering a number of times and finding the right direction. So it wasn't just his knowledge, it was his metacognitive skills. And this is a graph of some students after the problem-solving course, whose graph before the course was actually the one I showed you. And their graph on a more challenging problem afterwards showed that they were capable of first jumping in, oh well, it happens, but then stopping and saying, let's think about this, and ultimately moving in the right directions. That's metacognition. And then the last thing, the simplest example you all know about math anxiety, that's an outcome of math class, and it shapes the way people behave mathematically. It's one of many if you think about beliefs and dispositions. The question is, based on their experience in the classroom, are students going to emerge thinking math is all memorizing, or thinking maybe it's something you can figure out for yourself? Are they going to think, and it's been documented that the vast majority of students do think this, all problems can be solved in 5 minutes or less, typically by the method I've just been shown? Or, hey, I can work on problems for a long time and make progress as I grapple with them. Are they going to think, I'm supposed to have techniques at the ready, the one I've been shown, and if I don't remember how to do it, I'm out of luck? Or, hey, I'll give it a shot and I'll see what happens. All of those will be outcomes from their classroom experience. They're issues of agency, authority, in the sense not only of speaking with authority, but being able to author mathematics, owning the mathematics and who they are as mathematics people. All of those are aspects of thinking mathematically. So we need to have them in our minds as we think about what goes on in mathematics classrooms and what shapes them, which include assessments, etc. And of course, the classroom is where the action is. So I'm going to turn to the issue of the learning environment and to the properties of supportive learning environments. I'll say now, and I'll say a little bit more later, although there's thinking mathematically in the center of this figure, it could be thinking like a scientist, thinking like a writer, thinking like a historian, etc. You'll see why I say that in a minute. Our goal, broadly speaking, is to understand classrooms from which students emerge who are powerful thinkers. And we need a framework that tells us whether that's working or not. And what's important, that's the or not piece. So here's the big question that frames the next major chunk of what I'm going to talk about. What are 5 fundamental properties of classrooms from which students emerge as knowledgeable and resourceful thinkers and problem solvers in whatever domain? Why 5 or fewer? That's all you can really work on. If I gave you a list of 20 things, it's far too much. You do the same thing that students do, crumple it up and put it in your backpack. And if we're focusing on them, what properties do they have to have? Well, they'd better focus on what's important. They better cover the waterfront because you can't miss something essential. And if you care about impact, they better have integrity that can be worked so that each of them can be worked on in teacher communities and professional development, etc. Okay, you're about to meet the Teaching for Robust Understanding or TRUE framework. I'm going to do you a favor and spare you all the background research. I hope you appreciate that. What I'm going to do instead is show you just one video. I know many of the people in this group would like to spend hours upon hours of time digging into videos. We can only look at one briefly, and I'll use it to illustrate both the TRUE framework and then to problematize some of the issues that we should be thinking about and that I think will be central to ICCR's agenda. So the video is of a 6th grade Chicago classroom. Chicago is an urban school district. This school had a very high percentage of students who were minoritized, who got free and reduced lunch. They were working on one of our formative assessment lessons titled Translating Between Fractions, Decimals, and Percents. They're available on the web for free if you Google Mathematics Assessment Project Formative Assessment Lessons. This lesson started with groups of students being given 9 tiles that they cut apart, each of which had a decimal and a percent. And their job at first, except for the bottom right, if you notice, we'll get there. Their job at first was fill in the missing number. So move from decimals and percents to percents and vice versa. But then the tough challenge, place the cards in order of size. And any of you who've ever worked with elementary, middle school students, even some high school students, know that if you look at the middle row, some percentage of the students will say 375 is bigger than 75. So you're set up for some conflict. And the group of students is supposed to check that they agree. Then once they do, as though decimals and percents aren't enough, we give them area models and ask them to match the area models and explain their thinking. Put those in order of size, and then do the same with fractions and with number lines. So it's a pretty complex task. They need to check that they agree, and when they're all done, their tabletops look like this. The things in gray are things that they had to write in for themselves. Now, I'm going to show you a video of part of what happened. In that section of the video, 2 students are arguing about the right-hand column 1.25. There's a little bit more. The teacher circulates. You'll see students explaining to each other. It's important to see the classroom dynamics. This is a classroom community. Then when they get to the explanation for 1.25, one student has drawn this picture. And he says, that's 1.25. Another student says, no, it's not. First one says, oh, yes, it is. Each one of these things is about 5, and that adds up to 125. And the second one says, no. The first one's 100%. A whole is 100%, which is bigger. And the second one says, yeah, 125% is bigger. Doesn't that mean it should be bigger than just 1 square? And he leads the student through the conversation. What I'm going to show you is the video and then derive the framework, if you will, totally on mathematical behavior, arguing from examples to show you the abstraction of this framework. So here goes.
I don't know how many of you, well, everyone should remember this worksheet that we did that was fractions, decimals, and percents. Okay, and remember I said this was more of a pre-assessment to see what you know already and what we still need to work on. So based on what you did on this worksheet, we're going to do an activity today where you're going to be working with your partner most of the time. Okay, there are going to be times where you're going to work with your group, and I'll let you know when those times are. All right, so right now everyone's getting a worksheet. Once you and your partner have sorted your cards, so you're filling in the blanks first, then you're sorting them from left to right. That's why I don't want anything else on your desk, so you have space. Once you've sorted them, then you're going to turn and talk to your group members to check and challenge your explanation if they disagree. And remember, you have your sentence starters that you can use, and they're in your notebook as well, to challenge or each other's explanations or check for understanding.
So for 0, that's 50%. To change it into a decimal, you need to put the 0 because it's not a whole yet, because it's at 50, it's at half. Because the percent sign equals out of 100. So now the tens place would equal 50 because 10 times 5 equals 50. So now it's a decimal, so it's tens. So, and if you wanted to add a 0, it would be a 5. So it could be more easier to understand and review 50. I want to challenge Kashana on 80%. I think it's wrong.
Yes,
I disagree. I disagree with you. I disagree with you. I disagree with you, Kishana, because 80% is not equal 0.08%.
I disagree with you. Can you please clarify how did you get it?
Can you clarify how you did it?
So if you put 0.5, it means that you're practically saying that it's 50%. So change it to 5. Change it to just plain 5%.
So Kevin, do you know why she changed it to 5%?
Yes, because I was the only one doing it.
No, but like, do you understand why does she say to change it to 5%?
Yes.
Why?
Because 50%. Well, no, 5% I would just be like just one with decimal opposed to 50%.
Yeah. So let's go. We put next 12.5%.
Same thing.
Yeah. So then let's scoot this. Okay.
So I think I know how you got 1/4 because what you did was 1 whole because of the 1, and then when you did 1/4 because of the 25, which is 1/4 because 25 times 4 equals 100. Well, you can kind of get the idea of quarters, and then that's how you got 125% and 1 1/4.
Yeah, that's right. And then we got like 12.5% over here because it's 1/8. 1/2 equals 50%, and then to get 1/4, you have to divide that, which equals 25%, and then you have to divide that to get 1/8, and 25 divided by half, and then 2 equals 12.5%. And over here, it's 3/8. Well, I already explained that 1/8 equals 12.5%, and 12.5% times 3 equals, let me see, 37.5%, which is right. So 3/8 equals 37.5%. I know that you got 125% for 1.25, and that is right. That 1 point, and that is right. That 1 equals 125%. But the problem is the picture. You just shaded like this whole thing, and this, and even if it's not even a whole because you're missing this part and like.
I'm not missing any part. It's not like
yeah,
supposed
that's
to be
not close. 1 and 2, and it's not 125 equals 1 and a fourth.
No,
But
it's
this is
no, it's not
one-
supposed to be 1 and a fourth. It's actually most likely all these squares, it just equals 5 in each square.
How do
Like,
you know?
yeah, because if you would actually, like, if you would do like 5, 10, and it would all go to 125. Now I would like to see what you done.
I'm going to challenge you. What does 1 equal? 1 equals what percent? 1, the number 1, 100. What's greater, 125% or 1%? 100%. 125%.
125.
So doesn't that means that since 125% is greater, doesn't that means that 125% is more than 1?
Yes.
Tell me if this answer is right or wrong.
It's right.
Why is it right?
It's right because if it does wouldn't. Oh wait, now actually I think I know where you're going with this. The fraction for this would be
1 and
Yeah.
a fourth. That's where I'm going.
Why didn't you let me see it?
Sorry.
Okay. I'll note in passing that those students are more respectful, intellectual, and on topic than my colleagues in most faculty meetings. But putting that aside, remember the big question. What are 5 fundamental properties of classrooms from which students emerge as knowledgeable and resourceful thinkers and problem solvers? And I'm going to use the tape as a reference point for the framework that represents the distillation of the research on what matters. The first is the discipline makes a big difference, obviously. In this task, you saw the kids engaging in some very substantial mathematical thinking, not only the tasks, but the processes of arguing and convincing on logical mathematical grounds. A classroom will be effective to the degree it offers affordances for engagement with rich mathematical content and practices, all 4 of the ones that I mentioned in terms of mathematical thinking. A second fundamental aspect is cognitive demand. You can think of that in terms of Vygotsky's zone of proximal development. The question is, do students have the opportunity to engage in productive struggle? And I think you saw in this tape, there was quite a bit of it. Then the question is, who gets to engage? You've all seen classrooms in which the teacher and 2 or 3 students had wonderful mathematical conversations and the others were left by the wayside. That may be powerful mathematically for a few students, but it's not equitable, it's not a useful, powerful classroom. Because the outcome for every single student, as I was saying before, is their sense of mathematical agency or disciplinary agency. As I said, you can do this in any discipline. Their sense of whether they have their head around the materials, whether they've developed it, whether they own it, whether they think of themselves as mathematically powerful. And the question is, what affordances does a classroom offer for the development of this kind of thinking? Do students have the opportunity to get ideas on the table, critique others' ideas, build on them, etc.? So the affordances of the classroom make a big difference. And is the classroom a place in which student thinking is solicited and then it's turned around in such a way and adjustments are made so that the other dimensions live powerfully? If you hear the students are not connecting with the content in the right ways, do you make adjustments, etc.? Those are the dimensions of powerful classrooms. And a key thing, if you go back, the first dimension was about content. The other 4 are fundamentally about the learner's perspective. They're about how does the learner experience instruction. That's what's key. So what's important? I'm going to race through this, but here are 4 central points. First, from the research, if you focus on 5 dimensions, you're focusing on what matters. There's no essential hidden dimension. We have loads of evidence that says when classrooms do well on these 5 dimensions, the kids who emerge from them are powerful thinkers. Second, and again, echoing the main title of the talk and the leitmotif of David's work, the key idea is not, which most administrators have when they walk into a classroom, do I like what I see? Do I like what the teacher's doing? But what does instruction feel like from the point of view of the learner? And of all the slides we have that we've produced, this is probably my favorite. If you keep this in mind as you teach and you use it to frame your observations, it makes the biggest difference. From the point of view of the student, what's the big idea? How does it connect to what I know? How long do I have to think and make sense of things, and what happens when I get stuck? Can I hide under the desk? Can I be ignored, or do I get to participate? And in what ways are my ideas out there on the table? How do they feed classroom conversations? Attending to these questions as an individual is really what shapes powerful classrooms and student learnings. Third, too many frameworks tell you, do this and you'll be teaching well. No, TRUE is about problematizing. It's about asking, how can I do better about those dimensions given who I am, my teaching style, etc. And finally, for the same reason, PD is about building community that questions. It's not about telling them, do it this way. So those are key things about TRUE. Oops, that one doesn't belong there. And the idea is that you can use those ideas to problematize instruction and deepen research inquiry. So we can ask questions that help open things up to give students opportunities to think more deeply, and with the right tools, we can really study them. If we had more time and focus, I'd talk about tools in PD, but I'm almost done. So I want to talk, that's the TRUE website. We have loads of tools listed there, but I want to talk about research. And just note that each of the 5 dimensions opens up a world of opportunities for thinking about learners and thinking about the environment from the learner's perspective. Because we can ask, can we think about the construction of rich environments in disciplinary terms? And then can we take a close look at the ways that students put together their disciplinary understandings? Can we develop deeper understandings of the way, what's within reach for students, how they make connections, how they build understandings, what constitutes productive struggle? Can we understand the ways that instruction in very detailed and subtle ways is equitable or inequitable? I know there are studies going on now about how students are positioned and how the way they're positioned shapes their disciplinary identities. And that's critically important, because the issue is, what affordances do environments offer students to build their disciplinary identities? And how do we track the growth of those? And how do we keep track of whether ideas are made, whether and how ideas are made manageable within students' ZPD? So all of these dimensions are ripe for research. Now, the video I showed you wasn't too bad, all things considered. But just imagine if you had the capacity to zoom in on every conversation, if you could really capture the kinds of data you'd like in fine-grained detail and address all of the questions that I just outlined and more. Just imagine something like that as an opportunity. Think of all the possibilities that you have for opening up new dimensions of research when you have the tools that enable you to take a close look. Imagine doing so many of the things based on not only David's ideas, but the capacity that David has given you for moving forward in those kinds of inquiries. Now, I understand that's only one of many dimensions and directions that ICCR will be moving forward, but you have the tools and you have the background and connections and community to be doing some pretty amazing things. And that's part of the legacy and the space in the world of possibilities that David has given us. But let me return to the big picture with my 3 or 4 minutes left to frame some more issues to think about that also build on that legacy. I started with thinking mathematically, and again, now at this point, there is loads of analogous work, thinking like a physicist, thinking like a biologist, thinking like a historian, thinking like a writer, etc. First, you've got to understand what that entails, and then think about the affordances and constraints of the learning environment. But as has become more and more apparent in research analyses, all of that takes place within a really important cultural surround. People don't leave their identities, their biases, anything else at the classroom door when they enter the classroom. The same prejudices that lead to positioning students as inferior. And, you know, there's a research study that gives just as one anecdote. A Black student walking into an advanced calculus class and being greeted by, "Oh, what are you doing here?" There are studies within the learning environment that now examine the repeated positioning of students and the impact of what goes on. There are studies about the cultural surround, and they take place in various ways. One of them is what I just described within a culture, and that's what happens within classroom doors, and it reflects what's outside. And understanding how to trace that and understanding the impact is going to be one of the central issues of educational research for the next decades in the plural. The second is cross-cultural. Because one of the wonderful values of cross-cultural research is that it helps us see things that we just take for granted and don't think about. And if you think about the Lexicon Project, for example, all of the opportunities to hear colleagues from different countries talk about things that you've never noticed. That's one example of the wonderful kind of insight you can develop from the cultural surround. And David, partly because he made it so much fun to be around him and other people, brought together glorious collections of people, and those were not only fun, but they're a base for what's to come. So I think ICCR stands on an extremely firm foundation. It's connected across the globe, and there's a wonderful future to be had, with great thanks to my friend and colleague, David Clarke, and my thanks to all of you for the opportunity to share these ideas with you and for the colleagueship I've had through the years. I will turn it back to you, Carmel, or Esther, as the case may be.
Thank you so much, Alan. It really was a wonderful oration, and I especially like the way you've unpacked that complexity around thinking and working mathematically. I'm going to be thinking about that conversation between the two boys when they were relating 1.25 to its representation as a percentage. The manner in which that student was able to convince his classmate is really quite extraordinary. And I also noticed that he corrected himself when he said dividing by a half to dividing by 2. So there's, it was just a really fascinating little clip to watch. And I'll be thinking about, you know, what teaching practices would support that sort of conversation between pupils. Anyway, I'll just keep inviting everyone to continue to add questions and comments to the Q&A function of the webinar for Esther to draw upon. And it's now my pleasure to invite Esther to open her discussion with Alan, supported by your questions.
Cool. Thanks, Alan. Thanks, Carmel. Hi, everyone. I'm Esther Chen, and I have the privilege to work with David and his many colleagues in the past 6 years. I'm now also a lecturer at for the educational psychology programs at MGSE, and is part of the leadership team of the ICCR Hub. Now, I'll be moderating the Q&A segment of today's session. Please, as Carmel suggested, post your comments to the Q&A window in Zoom. Now, Ellen, this is not a question that you have to answer, but I am curious whether you think David is a devil or the angel on your shoulder based on your opening of your presentation. Now, we've got Yuso, who started the very first question, talking about the role of summative assessment in the classroom, and how it's something that a lot of people will have to use in the classroom, and how can you give student agency and voice through this particular practice? Ellen, could you comment on that?
The first issue you have to grapple with is whether the questions in your summative assessment are actually worth doing, because we have many summative assessments that are not. And I know there are a number of assessments in Australia that are actually quite good, so that's a start. Many years ago, so let's assume that you have some assessments that are actually worth doing. If you don't, you have a much larger political issue than I can address in a few minutes. Many years ago, we did professional development with a group of teachers, and we had some good assessments, and we took problems equivalent to those that would be in the summative assessments, and we did them at 3 or 4 times during the year. And the first time we did one, we brought the teachers together for a grading session. They graded, and then we said, now what are we going to do with these? And the teacher's response was, well, we've already assigned the numbers. There's nothing else to do. And we said, wait a second, let's see if we can do something productive. We still have a good 2/3 of the year left. And the thinking we'd like to see on these problems echoes the thinking we'd like to see on the end of year exams. And we said, let's break up the problems into, if it was an 8-point problem, those students who got a 1 and a 2, those who got a 3 and a 4, those who got a 5 and a 6, etc. Let's put those papers together and analyze them and ask ourselves, for those who got a 1 and a 2, what evidence of productive thinking did they display? Where did they get stuck? And where might instruction help move them forward? And how can we take these tasks and turn them into things that the students can use to learn from in our own classrooms? Do the same for the 3s and 4s and so on, and turn worthwhile formative assessment, worthwhile summative assessment tasks into worthwhile formative assessment tasks for the students. So Axiom 1, only have tasks, if you can help it, that are worth working on. B, if that's the case, you can make such things the object of classroom discussion and use them as part of the learning environment.
That's great. Thanks, Ellen. Now we've got another comment from Matt Scott. He said, it's a wonderful session, thank you. Are there studies exploring the shift in disposition of low SES students towards their approach to engaging with unfamiliar mathematical problems?
Mostly indirectly. So I'll say 2 things about that. One is a lot of the work on mathematical mindset was developed in classrooms with low SES minoritized students who had basically become convinced, I'm not a math person, I don't have the math gene, etc. And the idea that, hey, this is hard stuff, but if you have doing math, doing anything else is like developing athletic skill or building your muscles or anything else. It takes time, it takes work. And if you pitch in over time, you will see yourself get better at it. Now, there are some issues with the mindset work. It's gotten tied to things called grit, which basically blame the victim for not having enough grit. But the underlying idea that, A, if you convince yourself that it's worth digging in, and you're supported in that in an environment that rewards partial success for what it is, which is partial success, that does make a difference. And it does in particular make a difference for low SES students, not singled out as such, but as participants in environments that really provide and support growth opportunities. And that's the thing across the board, that most of the things that matter in mathematics learning are things that develop slowly over time. The quickies are the facts and procedures we throw at them. The things about developing agency, developing an identity and such, are things that develop over months and years. And it takes building instructional climates that support that. And when that happens, you hear students saying, I didn't think I could do this. And you hear teachers who've been supported in that, including in the formative assessment lessons. A teacher used a whole bunch of those. Sidebar, the Gates Foundation trusts nobody, so they sent people in to do evaluations of those lessons and didn't tell us. And among the comments that their researchers found were comments from teachers who said, I really underestimated my students. I didn't know they could do the kinds of things they're doing. And if the teacher as an act of faith gives them the opportunity and provides the context, then there's a positive feedback loop. The students develop more a sense of that, and the teacher is empowered to do more of that as well.
That's great. Thanks, Alan. We've got a question from Nicole, who's interested in your views on the influence of the mathematics curriculum, particularly at the senior secondary level, on what is taught and how it's taught.
Geez, I'd like to end on a happy note. It's not just the curriculum, it's curriculum and assessment. Both of those are generally constraining factors rather than enabling factors. So one of the main problems teachers have when they say, look, I would love to do all these wonderful things that we used to call it reform, that ambitious instruction talks about. I just don't have time because I have to race through the curriculum and there's the assessments. That was an argument in the late 1990s and early 2000s when the US was starting to implement reform curricula. And it took almost a decade to get the data. But the quick version is this. The traditional curricula at that time focused largely on facts and procedures, and people marched through it. We were talking about problem solving, conceptual reasoning and such. And the great fear was, if we don't teach it, our kids are going to die on the exams. And we finally got nice data-based evidence that said the kids who went through curricula that had a balanced diet of content, problem solving, and conceptual understanding did as well on skills-based tests as the kids who got just 100% diet of skills. And they beat the pants off of those kids on tests that called for thinking and problem solving. So in large measure, it's a very difficult act of faith. If you wind up teaching your students in ways that give them the opportunities to develop some of the content, that give them the opportunities in the way that you saw in that video, to develop ideas, to build on them, to make them their own, to do that kind of thinking, it may look like you're covering less, but in fact, so if you worry about the curriculum, it's, oh my God, I've taken so much time doing this. It may look like you're harming them, but in fact, they'll do at least as well. And I'm mindful of the clock, but I'll tell two stories very quickly. One is that in a project we did in San Francisco, I had a teacher say to me, look, Alan, I am extremely proud of my test scores. I think your ideas are interesting, but I'm going to give it 1 year. And if my average score goes down 1 point, I'm out of this project. And I said, that's cool. She was with us for 5 years. Okay. The other story is that it takes some rethinking of content that gives you more time to do these kinds of things. Take a very simple Algebra 2 task. Train A leaves the station traveling at 50 miles an hour. Train B leaves 3 hours later on a parallel track. When does train B catch up with train A? Okay. It's a 5-minute exercise. Okay, the second one is, the first one has been traveling. You want how long it takes to catch up. Call that T hours. The first one's gone 60 T miles. The second one has gone 60 T miles. The first is gone 50 times T plus 3 miles. Set them equal, you're done. Okay, I did that problem with a class of pre-service teachers. And what I said was, do this problem in the way that you feel most comfortable. Turns out half the students built tables. 50, 100, 150, 200, 250, etc. 0, 0, some did 60, some knew, nope, 0, 60, etc. They went all the way up. Some did graphs. Some did the algebra. And I started with the tables, and I asked all the questions like, can you see a pattern in the numbers? Can you see the second train catching up? And if you look at the pairs, the differences actually decrease by 10. Can you use that to predict the outcome without doing the whole table? Okay, so we went through that. Then we went to the graphs. And we asked the same kind of questions, and I asked, can you see all of the things that we talked about in the tables in your graphs? And some of them were easy and some were not. I'll leave as an exercise for you, where do you see catching up in the algebra? Okay, it turns out we spent an hour on that, but the kids who were most comfortable with the tables got to see how it led to and linked with the graphs and the algebra. And those who were comfortable with the other two got to ask deeper questions and make connections. So actually what happened was I took a 5-minute problem, I quote, wasted an hour on it, and we did 2 weeks of curriculum. So it is possible to do things like that. And with the formative assessment lessons, we now know that we can cover a good quarter of the curriculum through that kind of deep thinking about examples. So I know I went on and I'm mindful of the clock, but I thought that was worth an extended answer.
Absolutely, thanks, Alan. It's the message of looking for generative knowledge rather than knowledge that you can just recite and repeat to, I guess, make the teaching more efficient in many ways. So, Carmel, I think this will be the time that we've got for the Q&A. Would you say?
Yeah, I think it appears so. Which is unfortunate, I guess.
Yeah, we still have many questions there. We might try to find other ways for Ellen to respond to them to continue the conversation, if that's okay with Ellen.
Absolutely.
That's great, thanks. So Carmel, over to you.
That's really generous of you, Alan. We'll try to get get you to respond to those questions, and we'll be able to post it somewhere. Your last comment that you were talking about that problem and how it developed into more than one lesson reminds me of a Japanese lesson that I was once analysing, and I noticed that Yoshi in fact put up a question in the Q&A function, and it was a pair of simultaneous equations that really could be solved by inspection, but really ended up occupying the class for a period and a half, which was something I hadn't seen before, but it was a very, very, very rich experience, and it kind of mirrors, I think, what you were saying. So thank you very much, Esther, for moderating this Q&A segment so well. And of course, thank you, the audience, for providing such interesting, challenging and provocative questions. My final thanks on behalf of the ICCR are for Alan for delivering the inaugural David Clarke Memorial Lecture. Thank you so much, Alan. It's been an absolute pleasure to have had you take part in honouring David's legacy in this way. To all of you in the audience, we are grateful to have had your interest and support, and we look forward to meeting up again in the future, whether in real life or in the virtual space. But from all of us, please stay safe and well. Take care.